Hello, everybody, and welcome to Wednesday's After School Club called Junior Makers. My name is Kim. I am a community learning specialist with Do Space, and today we are going to be finishing up our series. We've been talking for the last several weeks about circuits, what they are, how they work, and doing some projects with them. And we are going to be finishing up our series with learning about what a breadboard is and how to make a circuit on a breadboard, which is really cool. And so, yeah, hopefully things will go well for that. So let's get started. So you're probably wondering, what is a breadboard? So it's this guy right here. This is our breadboard. So basically, a breadboard is a rectangular plastic board that with a bunch of tiny little holes in it. And these holes let you easily insert electronic components to prototype electronic circuits. Like you could see with our picture right here, we have our battery. It has a switch on our battery. We have a resistor, which we'll talk about, and an LED, a light emitting diode. And so prototype is just a fancy word for building and testing a version of something. So these are really, really great. Like if you want to get into robotics or like coding and doing things for robotics, this is a really great way to kind of start learning about circuitry to do that. And so you can always just like practice your circuitry on this before you need to maybe make a little bit more permanent or kind of more substantial version of what you want to do. And you're probably also thinking, why is it called a breadboard? Where does breadboard come from? So the word breadboard comes from because of the early days of electronics. People would drive nails or screws into wooden boards. A lot of times cutting boards that you see here, a lot of times that you cut your bread on, and so, if people were making their own bread, you would need a cutting board, and it made for a really great kind of flat surface to create those circuits. And because, as we've talked about in the past, things that are metal, like our picture shows, we have these metal screws. They are conductive, or they allow electricity to flow through them easily from our batteries. They made for really great components to kind of create a circuit with. So luckily, you don't have to do that. You don't have to ruin a cutting board to make your project. You can just use one of these plastic breadboards instead. And so here's some different options of what breadboards look like. We have a full version right here. We have a half version, which is what we have right now. And then we have a mini version as well. And so you are really able to use any version you would like if you buy any version. But a lot of times the half size that I have right here, they're really great for beginner level projects. So that is what I have for us to use today. So yeah. They also, another thing, they also come with, I'm going to see if I can get it. So you can see there are these like little notches on the side, and there's holes on the other. So if I had two of these, I could actually just click them right into place, and you'd actually be able to kind of extend your breadboard and working circuitry kind of space, which is really cool. So what is inside a breadboard that allows it to work? So basically, it says that there are these little metal clips, because they're conductive, that leads can fit into. And you're probably thinking, what is a lead? Basically, a lead is like the little metal legs. So this is like our wire that's covered in insulator. And basically the ends, these nice kind of non-bendy ends of our wire, are called the leads. And they're nice. They're able to just pop right in there really nicely. And that is because, as you can see in our picture on my PowerPoint, there are these metal clips that these leads just like kind of clip right onto when I put them inside one of these little holes. And so it just puts them in place, and it makes a nice, really nice connection, because as we know, the better your connection is, the better your circuit is going to work. And so that works with the leads like on your wires, leads with your LEDs or the legs from your LEDs. They're just like really nice and able to just kind of clip. If you can think of them as like kind of like little, chip clips or clothespins, things like that, that just kind of are able to open and close. They're already closed, but you can just slide the leads in between them, and then they just make a nice, good grasp on them. So you can kind of see in this picture just how the lead of this little component just fits and clips right nicely into this. And so basically, there are just rows and rows and rows and rows and rows of these. If we were to bust this open, we would be able to. Like if I were, oh, and actually I can kind of at least show you the back end a little bit. So you can see how all of these rows are all the metal clips. And the nice thing about this one, that I have, a lot of them too, they're actually, it's sticky back. So if I could make my component, my electrical component or my electrical circuit on the top, and if I needed to, I could take this off and slap it onto whatever I'm needing to power. If it needs, wheels or rotate, it has a motor on it or something like that, then it would be mobile, which is pretty cool. And so this is kind of what a general breadboard looks like. And so I'm going to kind of bring this up so you can kind of see. I'm thinking you might be able to see this a little bit better. But the pictures really kind of show you how our breadboards look. And the nice thing about them is that they're all labeled. They're all labeled the same way. So we have at the top our columns, and our columns are our letters. So we have on one side, we have A through E. So we have A on this side, E through this side. And then you can see in the middle, there's like a break or kind of like this bar. And then on the other side is F through J. So these are all of going to be our columns. And then we have also our rows. So across, as you go down on either side, you can see our rows are our numbers, and they go through 1 through 30. And let me bring this down into frame. There you go. So we have 1 through 30. And then on the sides, you can see we have 2 sides, or what are called our buses or rails. And these sides are where we plug in our wires from our battery. So you can see how they're labeled. So we have the right side is our positive side, and that is indicated with the plus sign at the top, and the red kind of line down the side. And then on the left side is our negative side, and that is indicated with our negative, or kind of our dash, our negative, and then the blue. Now, a lot of times we've talked about in the past how red, like when we're kind of color coding what's positive and what's negative, red is usually positive, indicates positive. Our black usually indicates negative. But on a lot of times on breadboards, it's indicated by blue. It's the same thing. It just allows, because our batteries are polarized, they have a positive side and a negative side. And some things like our LEDs, our little light diodes, they are also polarized, and we can tell that by the length of our legs. So we need to make sure that the positive wiring that comes from our battery needs to touch or connect to our positive lead or leg of our LED. So that's why those things are indicated that way. And so basically, a lot of times we are going to be dealing with the intersections. So if I say we are going to be putting something into hole C3, then you'll want to go over to column C, 1, 2, A, B, C, and then go down 1, 2, 3 holes. So that's where that cross section is. And then also, basically how our holes are all connected is that there are 5 sets of holes. So they're like our clips have a row. There's a row or a line of like 5 metal clips. And so that's why we have A through E and then F through J. And so basically everything is going to be electrically are going to be connected A through E and then F through J. So basically sometime there would need to be a circuit all on one side, or all of your components are going to be on one side or the other, or you would need to go across one row. And this is going to make a lot more sense when I do our example. But the holes, like basically our clips from our row 1 from A through J, or A through E. So E isn't connected to F on row 1. So these two sides aren't actually connected unless you connect them with wires like this. So, and also as we move down, each of these are our own set of clips. So A1 is not going to be connected to A2. So again, you would need to electrically connect them by putting those wires in. And so I'll kind of talk about examples of how that works when we get started. But the nice thing about all of this is that it allows for solderless connections. So soldering is, you may have seen it before, it's like there's a kind of like a wand and it gets really, really hot. Basically, it'd be like if we're connecting this wire to this LED light, we might solder them to connect together and basically heat up a material called solder, and then it just like fuses them together. And so then they're like basically connected that way. Well, a breadboard, and if you mess up, you can't easily fix it. Well, the nice thing about our breadboard is that you can create your connection, and if you made a mistake or you put things in the wrong hole, obviously you can correct those mistakes really easy, which is really nice, again, for prototyping or making an example first. So I say let's get started with what we're making. So these are the materials we are going to need. So first you're going to need a breadboard. So like I said, we have a half a breadboard. You are going to need an LED. So we have our little LED here. And again, it's polarized. So we can kind of tell that one leg is longer than the other. And our longer leg is our positive leg. And our short leg is our negative leg. You are going to need a 9-volt battery and a 9-volt battery snap connector. So this is nice because it just snaps right on top. And then I can easily, we have our wires, and I can easily put in, well, let's make sure I'm putting them in the right spots. So I can easily clip them into my breadboard just like that. So something to note when you're working with wires, whether you're doing them like this or like these, is you want to make sure that the wiring inside our insulator, so the color stuff on the outside, this red and this black, this is all called insulator. Basically, it makes it so we don't short circuit or things, wires don't touch, and that our electricity coming from our battery just goes like wonky wonk. So it just insulates everything. And so you just want to make sure that the wiring inside your insulator is solid. I have an example. This is just another kind of battery. You can kind of see, I'm hoping you can see I kind of bring it up to you a little closer. Hopefully it's in focus, but you can kind of see how this is all like thready, kind of thready, like string, like thread, or like, sewing thread. And when it's like that, it's really flexible and it's really hard to get into the holes. So try and find where the ends of your wires are nice and solid and just like one piece, because then they're not as flexible and they're a lot easier to put in your breadboard. And then you're going to need a resistor. And a resistor, so basically our little LED light right here, it only needs a couple of volts of electricity to make it light up. Well, our battery is a 9-volt. That's basically kind of like the amount of electricity that goes through the current. or the flow of the electricity. So there's 9 volts. Whenever it's like there's 9 volts of battery or electricity that is flowing through our circuit. And so, but our little LED light only needs like a couple of volts. And so a resistor, basically, it just kind of slows the flow of the electricity coming from the battery, and so that our LED doesn't burn out, which I had an issue with earlier today. So hopefully we don't have that issue today. No burnt out LEDs. And because if I were to connect this LED directly to my battery, if I were to like touch these all to, if I were to twist and touch them, there would be too much electricity flowing from our battery to our LED that would just pop it. So you need what's called a resistor to kind of resist that flow or that current of electricity that's coming from our battery. So a lot of times it's just easier to have a resistor than to find something that's under. Like if I were using this coin cell, like I have this little coin cell battery, this is just a 3-volt battery. And so I can easily just connect my LED light to it, and it's not going to be too much electricity through it. But 9 volts is too much, so that's why we need our resistor. And then we need some wires with some solid pins at the end. So like I have this one, these are like literally the pins are built in, which is really nice. But you could also, if you go to like a hardware store, a lot of times you're able to find wire just small wire like this, and you are able to cut the length that you want and then strip this insulator to get the wire exposed. And then that's a really easy way so you don't have to buy like a package of already exposed clips. And I think it would be a lot cheaper doing it this way too. And you would be able to cut them smaller so you don't have all this extra-ness going on. You would be able to put it small and kind of just like put it the length that you need, which makes it then cleaner. So yeah, so let's get started, friends. I'm going to stop sharing my screen so you can kind of have a better view of what we are going to be doing. So yeah, so what we're going to be doing first is, again, let's see if I have this right. Yeah, so we are going to be doing the first thing is we're going to be kind of making a circuit, and we're going to be creating the circuit all on one side. So like I said, these two sides are actually not connected. I could have a circuit going where all my wiring is all connected on this side, and then a second circuit on this side, and then have like no connection to each other. And then I'm going to do another configuration where it goes kind of the length of it, where we're going to have to connect each side. So, and that'll make a lot more sense. And so what we're going to, you can kind of see how our grid. So again, we have our columns at the top and then our rows on the side. And this is the first thing I'm going to do is I'm going to put our batteries in last a bit, but just to give you an example of how I'm going to put the battery wires in, they are going to be going in on just this one side. So my positive red wire is just going to go, if I put it even in just like the very first one, it's going to power this entire length. So as long as I have everything kind of connected in a thoughtful way, in an intentional way, which I'll talk about, then I could have this our positive black or red wire up here and our negative black wire down here. And as long as I had it in the same rows, so as you can see, my positive wires in row 1. So as long as I had some components row 1 and I was able to connect it all the way down to row 27 and then connect that to over here, it would be the whole length. So I'm not going to do that. I'm going to put this down. We're going to wait. So the first thing I'm going to put in is my LED. So again, our LEDs are polarized. Remember that they're polarized, and we can tell which is that our long leg is our positive and our short leg. So we have our long leg here, our short leg here. So this one's our negative leg and this one's our positive leg. Because this is our positive leg, I'm going to put that in I'm going to put that in whole. I'm going to go down to C3. So C, 1, 2, 3. So I'm going to put my first leg in C3. I'm just going to put this to the side for the time being. But I need to connect, I am needing to connect my positive bus or rail to row number 3. So I'm going to put in this red wire, and again, I'm pretty sure if I just go anywhere, I could put it down here, but as long as I connect it into row 3, so 1, 2, 3, now I'm going to have, once I connect my battery, I am going to be able to, these are going to be connected. So then I'm going to turn my little LED, and I'm going to put my negative leg, or my short leg, into row number C. I'm going to put it into C7. C7. So this is where you have to be pretty careful, because I could easily put it into D7 or B7, but I want it to be C. So column C and then row 7. So I'm going to put my negative leg into there and make sure, press it down so there's a nice good connection, that clip. So I have my wiring from my positive rail to my row number 3. I have my positive leg of my LED in C3, and then I'm putting my negative leg into C7. And then I'm going to take my resistor. And the nice thing about resistors is that they are not polarized. So I can put them in either way. It doesn't matter which leg goes where in terms of like the orientation of it. But I need to make sure that because my negative leg is in row number 7, I need to have one of my legs in row number 7. So I'm going to put it in A7. And then I'm going to put this anywhere in my negative rail. So you can kind of just even see how it's a little bit connected, a circle here. So we have positive to row number 3, then positive leg of our LED in row number 3, in column C, down to column C, row 7, and then my resistor is in row number 7 because my negative leg of my LED is in row number 7. And then I have my other leg of my resistor in my negative rail. So now if I connect my battery, I put on my, and again, I should be anywhere. I could put this down here and then this down here, and my light turns up because it's now connected. And even it doesn't quite look like a circle, but if you think about it, it's like it goes from here to here. So battery wire to red wire to LED, LED to resistor, resistor to our negative rail, and we've made a circuit. And so and now I can really put this, like if I want to put the negative thing there, or I can put it up here in rows, the very first row, we want to kind of make it easy like that. So you can see how we have successfully lit up our LED all on one side, but we can also do it across the 2 sides of our breadboard. So let's do that really quickly. So I'm going to take out some of my components, actually all of them, and we are going to go across. So now, when we were all on one side, we needed to make sure we connected the columns, like obviously the rows were important, you know, but it was also important to have the columns important. When we go across, what's going to be really important is that we make sure we're all in the same row or the same number. So, except for our batteries. Our batteries, it's not as big a deal because again, when we're connecting, it connects the entire length of our breadboard. So the first thing I'm going to do again is connect our LED. I'm going to do our LED first. So, but instead of connecting it down the same, like connecting the legs in the same column, I'm actually going to cross each side and we're going to be in the same row. So I'm going to choose row number 5. So I have 1, 2, if I can get a little closer, 1, 2, 3, 4, 5. So I'm going to go from, we'll just say, and I need, again, it's important to make sure you knows which side. I'm going to say my right side. This is my right side anyway. I'm going to say that's going to be my positive side. Is right is red. Right and red. R, start with R. So I'm going to put it in my positive leg, and we're just going to put it in 5D. And then I'm also going to put the negative leg in already, and I'm going to put it in 5F. So right across. But you just want to make sure that it's also in row number 5. So I have them both in number 5. Okay, so now I need to make sure that I'm connecting my red wire, and this is going to connect my row to my positive bus or rail. So again, it doesn't really matter which column, which letter you're in, as long as you're in the same row. So I'm just going to put it in row B, 5B, B5. And then I'm going to put it in just anywhere. Again, it doesn't matter. I can put it in any of these holes on my positive side. So I'll just put it in the first one. Boom. So we're all in again in row 5. Now for our resistor, it's the same thing. Again, it doesn't matter which side's which, as long as we're in the same row. So I'm going to put one leg into I5, maybe, into I5. So that's I5, and the second leg anywhere, again, anywhere on the negative rail on this side, because we're going across, right? Or to make it easier, we can put it in 5. 1, 2, 3, 4, 5. There we go. So now they're all in row number 5. So now you can see I've just kind of gone right across our board. So now all we have to do is connect our battery. So I have my red wires over here, so I know this is my positive side. So I'm going to put my positive wire, again, kind of anywhere. I'm just going to put it in the first hole of our red, of our row. So basically row number 1. And then the same thing with our negative. I'm just going to put it in the first hole in our negative. Oop, I bent my wire a little bit. And boom, there you go. We have a lit LED, and it has gone right across. And so as long as you keep everything, it does take a lot of good organization. You have to be organized. You have to kind of know where you're going. If you need to, you can always like write it down, like which hole is going where. There's positive or negative, the resistor, the LED. You can always do that as well. But it's a really cool way that you can just like create a circuit. And it kind of, you know, if you want to get into, a lot of times this is kind of a jumping off point for circuitry for robotics. So if you're into that, definitely look for more tutorials, different projects that you can use with making a breadboard. They are pretty cool. Once you kind of get the hang of them, they're a little confusing at first, but once you get the hang of it, they're a lot of fun to do and create. So you guys, thank you so much for joining me today for Junior Makers for our Wednesday after school club. Next week, we are going to be doing kind of a one-off. We are going to be doing a stop motion animation day. And then for October, we are going to be doing origami. So it should be a lot of fun. We're going to be making a lot of fun origami things. So hopefully you can join us again next time for our Wednesday after school club junior makers. So I hope you have a good rest of your week, and we'll see you next time. Bye-bye.